We want to welcome you to the Dallas Independent School District STEM Environmental Education Center. And we want to say a very special welcome to Stephen Foster. Thank you for joining us. Teachers, if you're watching and you have not signed up, please do so. Go to www.tiny.cc/6-8 restoration. Sign up for us, please. The program this morning will be about the solar system. During this virtual field trip, students will describe the physical properties, locations, and movements of the sun, planet, moons, meteors, asteroids, and comets. Understand that gravity is the force that governs the motion of our solar system, and describe the history and future of space exploration. Ms. Ramirez will tell you all about the sun, the planets, and the moon, and the moons. Mr. Dominguez, meteors, asteroids, and comets. History of space exploration by Mr. Monroe, and future of space exploration by Ms. Schramm. Students, you cannot ask a question during this, a verbal question during this program, but you can write in your questions, www.tiny.cc/question-answer. And now I'm going to stop sharing my screen. Tell you all about the sun, planets, and the
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about the sun, the planets, and the moon. So before we get started, I do want to show you guys some animal friends, and that is because our Earth is the only planet that we know of that can sustain life. So these are two of my favorite animals. These are insects, so they are invertebrates. These are Madagascar hissing cockroaches, and they get that name because when they get scared, they can make a loud hissing sound, sort of like a snake does. Now, these guys are native to, of course, Madagascar, which is near Africa, but they're really interesting. And of course, planet Earth has a variety of different life forms, both plants, animals, and a whole bunch of other things. So I'm gonna go ahead and put these guys up and we'll start our presentation all about the solar system. So let me get our screen share started. I do have a couple of essential questions for y'all. So hopefully by the end of this presentation, you'll be able to answer these two questions. The first is, what force holds the planets in their orbit around the sun and the moons in their orbit around the planets? The second is, you should be able to name the terrestrial planets, name the gas giants, and then tell your teacher differences between the terrestrial and the gas giants. So keep those two questions in mind as we go through the presentation today. So let's go ahead and get started. Let's first talk about the sun. So the solar system is the sun and all the bodies that orbit the sun. It is modeled using what's called a heliocentric or sun-centered model, so that we know that the sun is at the center of our solar system. Now, the sun is massive, but looks small because it is so far away. And we know that the sun is about 150 million kilometers away. That's also about 93 million miles, or we can also say it as 1 AU, which is an astronomical unit. And our sun is just a star, but like many other stars in our galaxies, it produces its own light via nuclear fusion. So our sun is located in the Orion spur of the Milky Way galaxy. So here you see the Milky Way galaxy. Here's our sun, and it's located in the Orion spur. It's about 25 to 28 light years from the galaxy center. Remember, a light year is a measurement of distance, not time. And the sun is a star, so it's a hot ball of hydrogen and helium gases. It has what's called differential rotation, which means that it rotates differently on its kind of near the equator than it does near the poles. So at the equator, it's about 25 days to rotate versus at the poles, it's about 35 days. So that's what we call differential rotation. And then you can see some of the more important parts of the structure of the sun. So now let's look at some of those planets. So when I was a kid, the way I learned my planets was by a super simple sentence, and that is, my very excellent mother just sent us nachos. So if you can remember that sentence, then you already know all of your planets in order from the sun. Now, also, when I was in elementary school, Pluto was considered a planet, but it's not anymore. So Pluto's been demoted to what's called a dwarf planet. So what we're going to be doing right now, we're going to be comparing and contrasting terrestrial planets versus the gas giants. And if we take a look at this little diagram here, we know that Mercury, Venus, Earth, and Mars are known as the terrestrial planets. Those four first planets are very dense and they're made out of rocks and minerals. They typically rotate slower and have shorter revolutions. So remember, a revolution is the time that it takes for a planet to go around the sun. So it makes sense that the planets closest to the sun would have a shorter revolution. Also, our four terrestrial planets, they have no rings and they have few satellites. Remember, satellites are just moons. So again, those four terrestrial planets are Mercury, Venus, Earth, and Mars. The last four planets in the solar system, those are going to be your gas giants. They are massive planets with thick atmospheres of mostly gas, but scientists believe they do have a solid core. They orbit far from the sun, so they're colder and they have many satellites or moons. So those gas giants include Jupiter, Saturn, Uranus, and Neptune. And again, here's just a quick review of the differences between the terrestrial and those gas planets. Now, of course, we live on planet Earth. We know planet Earth is a terrestrial planet. So now let's talk about those moons. Now, gravity, we have something called gravity. Gravity is the force by which a planet or other body draws objects towards its center. So the force of gravity keeps all of our planets in orbit around the sun, and it's that same force of gravity that keeps the moon in orbit around the Earth. So gravity is a super important force. Even though we can't see it, it is what is holding our planets in place, and it is what is holding the moon in place around our planet. So let's talk about some of these cool moons. So moons are natural satellites. They orbit planets. We live on planet Earth. Earth only has one moon, but some of the other planets have several moons. And you can see some of those numbers here in this diagram here. All of those gas giants have moons. More than 200 moons are found in our solar system, and some of those dwarf planets actually have moons too. Now, our moon has what's called synchronous rotation because it rotates and revolves at the same amount of time. And that is why we only see one side of the moon. So the moon orbits Earth about once every 27.3 days, and it also takes 27 days for it to rotate once around its axis. So that's what we mean by synchronous rotation. Now, when I was a kid, Jupiter was known to have the most number of moons. However, back in 2019, scientists actually discovered several new moons for Saturn. So Saturn now holds the record for the most number of moons, and that's why it's important to be up to date with new information and new science discoveries, because things do change. So Saturn now has the most number of moons with 82 moons, and that's quite a bit. And then my challenge for you guys is to explore our sun, the planets, and moons in our solar system. So research physical characteristics, maybe their internal structure, their location, and movements. And I'm going to take you guys to a solar system scope virtual site in just a second. But here's an example of my favorite planet. I'm going to see if you guys can guess what it is. My clues are it spins clockwise. It has clouds of sulfuric acid. It has crushing air pressure, 90 times that of Earth. It was named after the goddess of love and is also known as the morning star. So see if you guys can guess what planet that is. Now I'm going to take you guys to that solar system scope website so you can see what it's all about. This is a great website that can help you research the planets and the moons. So you can actually zoom in here. Let's zoom into Mars really quick. You can visit the planet virtually, and it also gives you some facts and information about the planet. You can also see its internal structure. So if you want to compare the internal structure of these planets to the other planets, you could do that. You can also zoom out and find some of the moons. You can also explore the constellation, and you can even zoom into the sun. So this is a fun little website for you guys to explore virtually. So that's all I have for you guys today on the sun, the planets, and the moon. We're going to give it back to Dr. Gorman to answer any questions.
Thank you, Mr. Maris. And we had a question from a student. What is the surface temperature of the sun? About 10,000 degrees Fahrenheit or 6,500 degrees Celsius. And now Mr. Dominguez is going to tell us about meteors, asteroids, and comets.
Hey guys, it's Mr. Dominguez. In this portion of your virtual trip, we'll be talking about smaller celestial objects like asteroids, meteors, meteorites, and comets. We'll talk about their differences, and we'll even make a model comet using dry ice, something that you can try at home or in your classroom. So why is it important to study these space rocks? Well, you can think of them as the remnants or leftovers of the formation process of our solar system. So understanding these rocks gives us a better understanding of our own solar system. In case you were wondering, I'm on NASA's website where you can check out all of these objects in real time and learn a little something more about them. So for example, you can check out their orbital period and their discovery date. All right, guys, let's get this presentation started. I hope you enjoy. All right, guys, let's start by defining these celestial objects. First, we have asteroids. Asteroids are smaller than a planet, but they are larger than the pebble-sized objects we call meteoroids. Most asteroids in our solar system are found in the main asteroid belt, a region between Mars and Jupiter. Sometimes one asteroid can smash into another. This can cause small pieces of the asteroid to break off. Those pieces are called meteoroids. Meteoroids can also come from comets. If a meteoroid comes close enough to Earth and enters Earth's atmosphere, it vaporizes and turns into a meteor, a streak of light in the sky. You guys might have referred to these before as shooting stars. Sometimes meteoroids don't vaporize completely in the atmosphere. In fact, sometimes they survive their trip through Earth's atmosphere and land on the Earth's surface. When they land on Earth, they are called meteorites. Now, finally, we have comets. Comets orbit the sun like asteroids, but comets are made of ice and dust, not rock. And here we have the anatomy of a comet, which we are going to use to help us build our model. So we have the nucleus, the coma, dust tail, ion tail. All right, so let's get started with that model. All right, guys, so we're going to build a comet. These are the materials you will need. Some rubbing alcohol, some pancake syrup, cornstarch, some vinegar, apple cider or white is fine, some soil, dirt, some water, a container. I have a beaker, but a cup will do. You will need some protective gloves because you are going to be working with dry ice, a Ziploc bag, and of course, the dry ice. And the dry ice needs to be broken down or smashed into a snow-like consistency. But that part, the smashing part, needs to be done by an adult. So teacher, parent, doesn't matter. It just can't be done by you because dry ice is pretty dangerous. It can burn you, it can get into your eye and really hurt you. So we don't want that to happen. You can handle it as long as you have the protective gloves on and you're not playing around with it because like I said, it can hurt you. So make sure that this entire model, the creation of this entire model is done under some sort of supervision, please. Now, each of these ingredients is representative of a component of a comet. And as we build our comet, I will explain to you what each of these ingredients represents, okay? So let's get started. All right, guys, so we are going to make a very special mixture that is going to be representative of all of the things that we have discovered in comets so far. And one of the things that we've found is methane, and we are going to use the rubbing alcohol to represent that methane. And you don't have to add too much of each of these ingredients, just enough to maybe fill the beaker or your cup. The next exciting thing that we found is organic material. And what do I mean by organic material? Well, I'm not referring to anything living, but instead the basic building blocks of life. So things like carbon, hydrogen, oxygen. So all of those elements that make up life have been found in comets, which is really awesome. So let's represent that with some syrup. The next thing that we found, which is also very, very exciting, is amino acids. And the amino acid that we've discovered in comets is glycine. And glycine is very important to the makeup of your DNA. So let's use the vinegar to represent those amino acids, that glycine. Now we are going to add a little bit of cornstarch, and the cornstarch is not representative of anything. It's just there to kind of hold our comet together. Now, another thing that we can't forget is the dust and rock particles that comets contain. So let's add that. So let's add a little bit of dirt. Now, a nickname that comets have are dirty snowballs. Now, that's because they're made of mostly ice and rock and dust particles and this mixture of different components. So now, the major part of our comet will be water, because comets are mostly made of water. So let's add that water. So we're going to, this mixture is mostly water. Now we are going to pour all of these components into a Ziploc bag. All right. And here comes the fun part, guys. All right, guys, so I needed to get my protective gloves for this part, and I actually ran to get another cup so I could get my dry ice with. And remember, comets are frozen celestial objects, so they are mostly made of frozen water. So we need to freeze our water, right? So our special mixture of comet components needs to be frozen in order for this to be a good comet model. So we are going to grab some dry ice carefully. So remember, this was the dry ice that your parent or teacher already smashed. So we are going to add some, and remember, I'm using gloves for this. So let me just grab some dry ice. And as you can see, what you are watching, that gas that you see is actually a process of something called sublimation. So this dry ice is going straight from a solid to a gas instead of reaching the liquid phase first. So let's freeze our wonderful mixture. And do not close the bag or you're gonna pop your Ziploc bag, and we don't want that to happen. So this is pretty exciting. So, and just kind of form it into a snowball, right? So remember, comets have that name, dirty snowball. So we're trying to make our best snowball. So this might take a little bit, guys, but eventually you are going to get a nice comet. So with all of the components that we've discovered so far. So I'll be back with our comet. All right, guys, so I'm back, and as you can see, I've successfully made a pretty good model of a comet. So I hope you were successful as well. I hope that you enjoyed this portion of your virtual trip and learned a little something about comets, meteors, and asteroids. I hope to see you guys next time. Enjoy the rest of your day.
Thank you, Mr. Dominguez. Question came in. What is the name of the most famous comet? And that would have to be Halley's Comet. Halley's Comet was first observed and recorded over 2,000 years ago. At that time, people didn't realize that it would come around again. Now, I don't know the duration of the time. I have to look that up to see how long before Halley's Comet comes back. But I'd like to see that. I know there was one that came through a couple of years ago, and they said you better get out and look at it because it'll be like 1,000 years before it comes back. So I made a special effort that night to get out. And of course, it was cloudy and I couldn't see it. And I don't guess I'll be around for the next time it comes around. And now, Mr. Monroe is going to tell you about the history of space exploration.
Good morning, everyone. We're going to be looking at a brief history of space exploration. And it's quite interesting. I've learned a few things about the history of space exploration by doing a little research. I couldn't remember right off who or what was the first live organism to actually go into space. And by doing the research, I found that out. Now, listen, guys, there are a couple of things I want you to be able to remember from this too. In what year did the first rocket reach the boundary of space? And who was the first man on the moon? Some of you probably already know that. But you know what? I liken to that. Maybe a test that you'll have to take later on that you may have to use those as answers. Or it could be that you will be on, I've always dreamed about being on a game show, and the question came up about certain types of history. And I've always dreamed that someday I would win $1 million. I think I remember a game called Who Wants to Be a Millionaire? And I always had dreams about being on that. Well, needless to say, let's get started. And what I'm going to do is show you a different screen that actually I'm going to share my screen with you. And it actually is a short presentation that's going to give you a brief history about space exploration. So bear with me while I load this up and we'll get started. In this presentation, you're going to investigate the history of space exploration, including space transportation. You know, man has always aspired to explore the unexplored. We know that. And to understand what is not understood. Seems like that is all about science, doesn't it? The Earth, our sun, our solar system, even our galaxy is tiny in comparison to the known universe. Space has therefore been a fascination to explorers and scientists alike for many years. Very early space exploration started a long time ago. Before there was space travel, or before it was even possible, space exploration was performed by studying the sky basically with the naked eye, just looking up at the sky. Ancient scholars developed an understanding of the stars, the planets, and their movements based on what they had observed. Very early space exploration came with the development of the telescope in the early 17th century. Astronomical observations became more detailed and accurate. However, it was the dramatic technological advances of the second half of the 20th century that enabled us to substantially increase our knowledge of space. Early rockets. Well, the principle of the rocket has been around for a long time. The earliest were used as weapons hundreds of years ago. Early rockets, wow. The rocket produces movement by burning fuel. This shoots out hot gases out of one end, sending the rocket in the other direction. In order for burning to take place, there must be fuel and oxygen. Since there is no air in space, rockets must have their own oxygen source. This allows them to be used for space travel. First rockets in space. First rocket that was able to fly high enough to be considered in space was the V-2 missile, which Germany had produced. This weapon was developed by a German scientist in the Second World War. The technology was used for rockets in early space exploration. Now, before we actually put a rocket in orbit, in 1957, the Soviet Union launched a rocket that sent the first man-made satellite to orbit around the Earth. The satellite named Sputnik 1 orbited for 57 days before burning up upon re-entry into the Earth's atmosphere. First life in space. The next question was, could a human travel into space? And I'm going to stop right there and bring up some other details that are not listed in this presentation. But listen, the V-2 rocket was very instrumental in space exploration. In fact, the first animals that went into space were launched using an adaptive V-2 rocket. In 1947, fruit flies were sent into space. Now, they didn't orbit, but they were sent into the boundary of space using a V-2 rocket. And these fruit flies even carried a food supply with them in the form of corn. And then in 1949, the first monkey was put in a specially adapted V-2 rocket, and it flew up, or it flew from the Earth about 83 miles from Earth. Now, first life in space, these are considered the lives that went into orbit around our planet. Now, some scientists had believed that life would not be able to function during space travel. It was decided that an animal would be sent first to ensure the safety of the journey. Now, the fruit flies and that first monkey that went into space, they did not survive. And just a few weeks after the successful launch of Sputnik 1, the Soviet launched another satellite called Sputnik 2. Sputnik 2 had a passenger for its journey, and it was a dog named Laika. Now, Laika, guess what? She was just a stray dog found on the streets of Moscow. So I guess it wasn't any loss to anyone that they put her in there. Now, sending her up, sending something alive, we had to have some type of oxygen, okay? And a fan that kept Laika cool, a harness to keep her safe, enough food for the trip, a way of collecting the waste of the dog. Unfortunately, Laika did not survive the trip. However, she was placed in history as the first living thing to orbit the Earth. The first human in space on April 12, 1961, Russian astronaut Yuri Gagarin became the first human in space orbiting the Earth once. Gagarin traveled in a spacecraft named Vostok 1. It was unknown how humans would react to being in space, so the flight was controlled actually from the ground. Once the spacecraft had been successfully launched, the rocket part dropped off the craft and returned to Earth. Only the capsule containing Gagarin was sent into orbit. Upon re-entry into the Earth's atmosphere, Gagarin ejected from the craft and parachuted safely to the ground. In 1969, there was a race going on, and in 1969, American astronaut Neil Armstrong became the first man to set foot on the moon, proclaiming, "That's one small step for man and one giant step for mankind." The rocket-propelled spacecraft that made the journey to the moon was the Apollo 11 as part of NASA's Apollo project. In the year 2010, US President Barack Obama made the following statement: "By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to the Earth. A landing on Mars will follow." The distance between Mars and Earth is about 55 million kilometers. Using current technology, it is estimated that a journey of that distance and back would take over a year. The biggest obstacle to space travel is the extremely large distances. Scientists are looking to improve spacecraft technology. Could a rocket be made that does not require the burning of fuel? You guys are going to learn a little bit more about that later on, because I believe your next part of your virtual field trip deals with space exploration in the future. But I will say this, listen, space exploration has come with a cost. It's very expensive, not only just economically or money-wise, but in the year of 1986, tragedy did strike. The Challenger exploded shortly after the launch because of a fuel system failure, and it killed the 7 astronauts that were aboard. This accident reminded the world of the dangers of space travel and the bravery that all astronauts have. Now, I'm going to turn it back over to Dr. Gorman. So if any of you, I'm going to stop sharing my screen and turn it back over to him. So if any of you have any questions, I bet he can answer those for you.
Thank you, Mr. Monroe. And question came in, have I ever had any experience with anything to deal with space? A very limited experience. Way back in the late 60s, I spent a couple of years of my life over in the Southeast Asia area, flying in a search and rescue helicopter. And the helicopter that we were using had been used to pick up some of the astronauts when they came back to Earth. Now, I do not know which ones, and I've tried to find out which astronauts and which mission it was, but I've been very unsuccessful. I don't think anybody has a record of that. Okay, and excuse me. And now Ms. Schramm is going to tell you about the future of space exploration.
Hey everybody, good morning. So we are talking all about the future of space exploration. And let's see, where's it going? Okay, so luckily for you, and mostly for me, I was recently at a conference in NASA about space exploration. And there's a lot of exciting things happening over there at NASA and in other private sectors. So let's get going. At the end of my part of the field trip, you'll be able to describe the future of space exploration, including the types of equipment and transportation needed for space travel. So right now at NASA, they are working on the new Artemis mission. You may have heard about this before, but it's humanity's return to the moon. So NASA is planning on sending people back to the moon by 2024. I believe it just was pushed back to 2025, but still that's coming up. And then as you can see, little Mars peeking up behind there. The next phases of the mission are going to be taking people from the moon all the way to Mars. So let's get going and kind of see more about this Artemis mission. That's what I'm going to focus on mostly, because that's about to launch soon. And that's what NASA is working on, but we'll touch on a few other things that are happening in space exploration as well. So I'm just going to read the NASA mission statement for Artemis. So with the Artemis missions, NASA will land the first woman and the first person of color on the moon, using innovative technologies to explore more of the lunar surface than ever before. We will collaborate with commercial and international partners and establish the first long-term presence on the moon. Then we will use what we learn on and around the moon to take the next giant leap, sending the first astronauts to Mars. And I found that mission statement on nasa.gov. Of course, there's tons and tons and tons of information about the Artemis missions, the different phases, and everything that's going on over there. So like that mission statement says, they're planning on sending the first woman and the first person of color to the moon, which is huge. And they are going to be building a lunar base so that astronauts and people are constantly on the moon. So we haven't had anyone on the moon since the 70s. So now they're trying to expand our exploration and build a base out there. So why are they called Artemis? So Artemis and Apollo namesake. So of course we know that the missions that sent us to the moon the first time were the Apollo missions. And so they named Artemis the next missions because Artemis is the mythological Greek goddess of the moon and twin sister of Apollo. So Apollo was, of course, like I said, the name of the original mission landing on Mars. And so now they've named the twin sister, the second one, Artemis. And the name of the crewed spacecraft is Orion. So we're going to talk about the Orion spacecraft in just a minute. But Orion is one of the most recognizable constellations in the sky. And it is the name of the hunting companion of Artemis in mythology. So it's fitting that the capsule that's going to take the astronauts on the Artemis missions is named Orion. And they're big into all the symbolism over there at NASA. And I thought that was fun, little background information. All right, so rocket power. First off, how are we getting there? Of course, with all that equipment and trying to build a lunar base, you're gonna need to carry a lot into space. And so that requires really, really powerful rockets. So this on the far left is the Saturn V. That was what took us to the moon in the first place. And now on the right, you can see the SLS rockets that they are setting up to take Artemis missions to the moon. So the first one right here, if you look in the middle, the SLS Block 1, that's what's going to be going up first. That's what's already set up at the Kennedy Space Center in Florida. They are already set up for their wet dress rehearsals. So basically they set up the rocket like they're gonna launch and do everything except for press go. So they actually have already done the wet dress rehearsal, and the first Artemis mission is supposed to launch on March 20th of this year. So if I were you, I'd mark your calendars because that's gonna be awesome to watch. So the first mission is not going to be crewed, so there's not going to be people. But once there are people, the second SLS rocket is coming in. So this is the SLS, Block 2 cargo rocket. And of course, that's going to be much bigger because it's going to be holding more things, and also the Orion spacecraft, which will have the astronauts inside. So that will be for Artemis 2 mission and Artemis 3. And you can see compared to the Saturn V rocket, it's almost the same size. And the Saturn V is really huge. I was able to go visit one of the models of the rockets, and it filled up like an entire huge like football arena thing. So it's really, really big. Anywho, okay. So the Orion spacecraft, this is what is going to, well, it's a mock-up of what's going to hold the astronauts when they go to the moon and then be on to Mars. So it is large enough for 4 astronauts to fit. And also they can stay in there to up to 21 days. So there's enough space for them to live and work for 21 days. I've seen the mock-up of it, and I don't know if I could stand to be in there with 3 other people for 21 days, but I am also not going to be an astronaut. So, all right, so what else do we need when we get there? So we've got our rocket, we've got the capsule that's going to travel there. So what else do we need? Well, they're planning on building a permanent space station around the moon. So right now, you know, we have the International Space Station. It's been up there for a long time. Pretty soon, NASA is not going to be using that any longer. It's unsure if private companies are going to buy it and take it over, or if they're just going to let it kind of deteriorate and dispose of it. But so they're going to make a new space station called Gateway. And they also are going to build permanent structures on the moon that I mentioned earlier. That also means that they're going to have a new human landing system. So if they're going to have Gateway where Orion can connect, they're also going to have something that will allow the astronauts to land on the moon to go to those other permanent structures. So let's see what those look like. Here is a mock-up of what Gateway will look like. And you can see here's the Orion spacecraft that we talked about earlier, and it's docking here at Gateway. And then we have the new human landing system. And this is once again also a mock-up because it hasn't happened yet. But this actually looks pretty similar to the original lunar lander, except for it's got these crazy solar panel wings on the sides. But if you look at the bottom of the structure, especially if you have a side-by-side picture, it looks really similar to the first lunar lander. All right, so of course, once we get there, are we going to be walking everywhere? No, they're gonna need vehicles to explore the moon. So that's when the Lunar Rover comes in. So these are the original, the Apollo Lunar Rovers. And we've got the astronauts there, and they're able to drive them around. They kind of look like little golf carts or ATVs. But they are, of course, getting new ones for Artemis. It's been a while. So we've got new technology, new mock-ups. This one even looks more like a 4-wheeler ATV to me. So we're kind of gonna see what those look like in the future. But also we have a STEM challenge. I highly recommend you do this later. I actually did one of these STEM challenges when I was at my conference, and it was so fun. So all you need is rubber bands, a little bit of tape, and cardboard. And you can build your own little lunar rover, and it's pretty fun. So I would recommend you go to the NASA website, just Google NASA STEM challenges, and you should be able to find it pretty easy. All right, so here's more information. I'm not going to read all of this. I could go on and on, but I will not. So you're welcome. So here is just a graphic of Artemis 1 and the plans of what's going on and all that they plan to do and all the different stops. So I will save that for you to look up if you're interested. So some other things besides the Artemis mission to look out for: the James Webb Telescope launched, I want to say late December of last year. So it is going out into space right now and getting further and further. And we should be receiving the first images from this telescope in the summer of this summer. So that's going to be really exciting. And why is it very exciting? Because we're going to be able to see further back in time and further back into space than we ever have before. So right now, the most high-tech telescope that we have is the Hubble Ultra Deep Field Telescope. And Hubble has been up in space since the 90s. So since I was like a baby. So it's been up for a very long time. And so now they've created the James Webb Telescope, and it's going to be able to see even further into space. And the design is really bananas. It looks like a, I don't know, honeycomb on a spacecraft. It's really, really cool. And it should be able to see back 200 million years back in time towards the beginning of the universe. So that should be very, very exciting. Some other things that are happening, not just NASA or government funded programs, but we also have commercial spacecraft. So Blue Origin is the rocket that took Jeff Bezos. And so Jeff Bezos wrote this. Other actors, William Shatner, other celebrities have ridden on Blue Origin. And basically it takes them up for an 11-minute flight. They go up technically just across the barrier into space. They get to see Earth and come back down. So this is like a new development in space tourism. Of course, it's very, very expensive, but it is something that's going into the future. So you don't have to be a NASA astronaut now to go into space. You just have to have a ton of money. Also SpaceX, which is Elon Musk's program. And he is also developing programs to visit the moon. So once again, this is not government funded, this is the private sector. And of course, Elon Musk has a lot of money and is also very interested in going to space and going to Mars and beyond. So that's another thing that you can look into, but for the sake of time, I don't have enough time to do it. So that is all I have for you. Thank you so much. Oh, there's the Artemis video, but once again, I don't have time. So I highly encourage you to check out those things if you're interested. One last thing I wanted to share with you is when I was at that conference, they had a panel of astronauts. And one thing they wanted to tell kids is you don't necessarily have to be a rocket scientist or an astronaut to be a part of space exploration. They need all sorts of different people to help support the missions. So if you're interested, I highly recommend looking into it. All right, thank you so much, and I'll see you next time.
Thank you, Ms. Ram. Excuse me. And going along with what she was just talking about, just recently, the United States developed a new military called space. It's not just the Army and the Navy, the Marines and the Air Force anymore. It's also the space thing. That would be very interesting. I would have really liked to have looked into that. But whenever I was in the service, they hadn't even got to the moon yet. So it was not around at that time. Thank you guys so much for joining us today. And we do appreciate it. During this virtual field trip, students describe the physical properties, locations, and movements of the sun, planets, moons, meteors, asteroids, and comets. Understood that gravity is the force that governs the motion of our solar system, and describe the history and the future of space exploration. Ms. Ramirez talked about the sun, planets, and the moons. Mr. Dominguez, the meteors, asteroids, and comets. Mr. Monroe, history of space exploration, and Ms. Ram, the future of space exploration. Thank you so much for joining us. Teachers, if you would, we'd appreciate it if you'd go to www.tiny.cc/6space8feedback. Fill out that short form and send it back to us. We certainly would appreciate your input on this. You have a great rest of a beautiful day. And more importantly, guys, have a great rest of your life.